Method 1. Find the HCF of 32 and 24. Step 1. Find the prime factors of the given numbers by the repeated division method. First, find the prime factors of 32. Begin with the smallest prime number 2. Dividing 32 by 2, we get 16. On dividing 16 by 2, we get 8. Again, we divide 8 by 2 to get 4. And 4 divided by 2 gives 2. As 2 is a prime number, we divide it by itself and get 1 as the quotient. Thus, the prime factorization of 32 is 2 into 2 into 2 into 2 into 2. Now, find the prime factors of 24. Dividing 24 by 2, we get 12. Now, divide 12 by 2 to get 6. Divide 6 by 2 to get 3. 3 is a prime number, so we divide it by itself and get 1 as a quotient. Thus, the prime factorization of 24 is 2 into 2 into 2 into 3. Step 2. Circle the common prime factors of the given numbers. Here, the common factors are 2, 2 and 2. Step 3. The product of the common prime factors of the numbers gives the HCF. Thus, the HCF of 32 and 24 is equal to 2 into 2 into 2 is equal to 8. Let us take another example. Find the HCF of 44, 77 and 110. First, we find the prime factorization of all these numbers individually by repeated division method. We get the prime factorization of 44 as 2 into 2 into 11, 77 as 7 into 11, and 110 as 2 into 5 into 11. Next, circle the common prime factors of 44, 77 and 110. Here, the common factor is only 11. Since there is only one common factor here, the HCF of these numbers is also the same, that is 11. Now, let us look at method 2. Let us find the HCF of 32 and 24 again using this method. Here, we will be finding the prime factors of both the numbers together. Step 1. Find the least prime factor that divides the given numbers completely. Begin with the smallest prime number, that is 2. As the numbers 32 and 24 are even numbers, they are divisible by 2. So, 32 divided by 2, we get 16. And 24 divided by 2 is equal to 12. Step 2. Continue in this manner until the quotients obtained are not divisible by the same prime number, and then stop the division. Now we divide the numbers 16 and 12 by 2. So, 16 divided by 2, we get 8, and 12 divided by 2 is equal to 6. We again divide the numbers 8 and 6 by 2 to get 4 and 3. Now here, numbers 4 and 3 are not divisible by the same prime number. Thus, we stop the division here. Step 3. The product of the common prime factors of the numbers gives the HCF. The numbers we wrote on the left are the common prime factors. Thus, the HCF of 32 and 24 is equal to 2 into 2 into 2 is equal to 8. Let us take another example. Find the HCF of 120, 100 and 140. Begin with the smallest prime number that divides all these numbers completely, and continue in this manner until the quotients obtained are not divisible by the same prime number, and then stop the division. Now, here numbers 6, 5 and 7 are not divisible by the same prime number. Thus, we stop the division here. Thus, the HCF of 120, 100 and 140 is equal to 2 into 2 into 5 is equal to 20. So, take an example. Find the LCM of 25, 15, 30 by prime factorization. Step 1. Find the prime factorization of the numbers by repeated division method. First, we find the prime factors of the number 25. Think of the smallest prime number to divide 25. We know that 25 is not divisible by 2 and 3, but it is divisible by 5. So, we divide 25 by 5. We get 5. Now, we get 5 as the new dividend. It is a prime number. Hence, the least prime number which divides it is 5. So, 5 divided by 5 is equal to 1. Now, we have the quotient as 1. Thus, the prime factorization of 25 is 5 into 5. Now, we find the prime factors for the next number 15. We know 15 is not divisible by 2. So, we take the next prime number, that is 3. Dividing 15 by 3, we get the quotient 5. 5 is a prime number. So, the next smallest prime number which can divide it is 5. Therefore, we divide 5 by 5, which is equal to 1. Here we got the quotient as 1. So, we get prime factorization of 15 as 3 into 5. Similarly, we find the prime factorization of the last number 30. We write the prime factorization of 30 as 2 into 3 into 5. Step 2. Circle the common prime factors of all the given numbers. Here, the common prime factor is 5. Step 3. Underline the remaining common prime factors of any two numbers. Here we get the remaining common factor as 3. Step 4. List the uncommon prime factors of all the given numbers. Finally, the uncommon factors are 2 and 5. Step 5. The LCM is the product of the common prime factors of all the numbers, remaining common prime factors of any two numbers, and uncommon prime factors of all the numbers. Thus, LCM of 25, 15 and 30 is equal to 5 into 3 into 2 into 5 is equal to 150. Now, let us solve another example. Find the LCM of 21 and 63 by the prime factorization method. We find the prime factors of 21 and 63 by repeated division method. The prime factorization of 21 is 3 into 7. The prime factorization of 63 is 3 into 3 into 7. Now, let us circle the common prime factors of 21 and 63. Here, the common prime factors are 3 and 7. Now, list the uncommon prime factors of 21 and 63. The uncommon prime factor is 3. Lastly, we find the product of the common prime factors and uncommon prime factors of all the numbers to get LCM. Thus, LCM of 21 and 63 is equal to 3 into 7 into 3 is equal to 63.